Hello everyone, my name is Jose Fernando Muñoz, and today with my lab partner Salome Buritica, we are going to talk about environmentally responsible redox chemistry. And this presentation is an example or an experiment of convenient oxidation methodology without chromium waste. For the part of the index, we have four important parts of the presentation. We have the introduction, methodology, the results, and finally, little conclusions.
Okay, I am going to start talking about the introduction of the article. Redox reactions are fundamental in organic synthesis, and undergraduate chemistry labs often include examples that use chromium 4 as an oxidant. However, there is growing concern about the environmental impact of chromium waste generated by these reactions. In response to the need to incorporate green chemistry principles and demonstrate that chemistry can be beneficial rather than harmful to the environment, this experiment introduced a cleaner methodology. And the overall objective in this investigation is to present a simple and environmentally responsible reaction sequence that illustrates the reciprocity of oxidation and reduction process using MAC3, a recyclable oxidant.
Okay, guys, continue with the presentation. We have the methodology of the experiment, and this methodology is divided in two important steps. First, we have the oxidation of benzoin to benzyl, and then we have the reduction of benzyl to mesohydrobenzoin. For the part of the oxidation of benzoin, first we need to add the matrix to a solution of benzoin in solvent. Then the mixture is heated to reflux, and the reaction is monitored by TLC, that is thin layer chromatography. To track its progress, it is checked by the reaction is complete. If the reaction is complete, the matrix solution is cooled and decanted. Then the residue is washed with sodium. The combined solution is filtered through solute, and then the solvent is removed with a rotatory evaporator. The obtained residue is recrystallized, and finally we have the benzyl. And the benzyl is characterized by melting point and IR spectrum. After obtaining the benzyl, the process continues with the reduction of benzyl to mesohydrobenzoin. The benzyl is dissolved in ethanol. Sodium borohydride is added to the solution. It is observed if the color disappears. If the color disappears, it's diluted with water and heat. The solution is cooled slowly to precipitate the product, and the product is collected by vacuum filtration. Lastly, the mesohydrobenzoin is characterized by melting point and IR spectrum.
And now I'm going to talk about the results and some discussion about it. According to the article, typical of expected yields from the oxidation step from benzoin to benzyl are around 80%. Low recoveries are usually due to insufficient or improper washing of the material, or in some cases, excessively long reflux times. For the reduction step from benzyl to mesohydrobenzoin, typical yields range between 30 and 35% under the described experimental conditions. The mesoisomer is expected to precipitate predominantly. This outcome opens the door to discussions on stereochemistry, including the theoretical number of possible isomers, their formation, and the reasons why only one is isolated. The products from both steps, benzyl and mesohydrobenzoin, are characterized using melting point determination and IR spectroscopy.
And finally, we have a little conclusions about the experiment. Well, this laboratory exercise allows students to explore reciprocal nature of oxidation and reduction reactions in an environmentally conscious manner. The use of MACTRIP as an oxidant eliminates potential health and environmental risk associated with traditional chromium-based oxidants. Although MACTRIP may initially appear expensive, its ability to be fully recycled at a low operational cost makes it a cost-effective long-term option. In addition to reinforcing redox chemistry concepts, the experiment emphasizes essential laboratory techniques and places them within the context of green chemistry principles, preparing students for more sustainable chemical practice. This experiment serves as a valuable example of how organic chemistry education and sustainability principles can be integrated into the university curriculum. That's it for our presentation. Thank you so much for your attention and goodbye.